In this simple task, our problem is to size this resistance if we know current that flows through this resistance. And this is a very simple task and may be solved by a few different ways. So we may perform on-diagram analysis, we may apply Kirchhoff's laws and Ohm's law alternately, and also we may utilize Thevenin's or Norton's theorem, substitution theorem, and superposition theorem. For a complex circuit, however, we have to apply a nodal analysis or computer simulations, piece-by simulations. So let me start a nodal analysis approach. For this circuit we have to write down a nodal equation, a single equation like here. From this equation we may calculate voltage V, which is a function of circuit parameters, also conductance that we are looking for. We have to supplement this equation with an equation that takes into account knowledge of the current that flows through resistance. So this is the equation. This voltage is current divided by a conductance that we are looking for. Now we have to solve this system of equations to find a value of G sub x. And this is shown below here. If we have G sub x, we may calculate R sub x, which is 6 ohm. As you can see, a very simple task. However, well, calculations are not very complex, but also not very simple. A piece-piece simulation now. So we have to build a circuit diagram, and as we are looking for one parameter, we have to perform parametric analysis. We have to name this resistance, well, R sub 4, but its value is R variable in brackets. And then we have to recall from the library such part. Parameters are these values arbitrary. Then we have to obviously set values of all other elements. We may add current, a voltage source, such that we have a current that we are looking for. And then we may perform parametric analysis. Parametric analysis means we have to select a global parameter. This is our parameter, start value 1, end value 10, with increment 0.1. Then, after simulation is completed, we obtain this window, available selections, and obviously we select all resistances. Then we have to select a trace. Our trace is current of a voltage source V3, and we have this trace shown here. So this is a current that flows through this resistance that we are looking for as a function of resistance. And now we are looking for the level of 0.5, and for this level search forward level 0.5. For this level we may read that value that we are looking for is 6, and this completes simulation. Now this is alternate display of the same window. Now Thevenin's theorem approach. So we may replace all the circuit as seen from these resistor terminals by its Thevenin equivalent, like shown here at the right side. We have to find E sub O and R sub T, and then obviously very easily we may calculate mesh current. We know this mesh current, and from this equation we may find a resistance that we are looking for. So below we have two circuits for calculation of E sub O and R sub T. Obviously these circuits are trivial, very simple, and these calculations are very simple. If we set these values into this equation, we obtain the following equation, and from this equation it is only one simple step to find that resistance that we are looking for is 6 ohm. And finally, a substitution theorem approach and also superposition theorem applied in this solution. So we may replace an element that we are looking for by a current source. We know current, an element current. Then we may substitute this element by a current source, like here at the right side. Now, for our calculations, we have this circuit we know all the values, parameters of this circuit, so calculations are very simple. We may utilize superposition theorem to find this voltage, as we are looking for this voltage to find a resistance. So below we have two circuits obtained from this circuit, a circuit with a voltage source, a circuit with a current source. Once again, these circuits are trivial. The calculation of components of this voltage is very simple. We have this voltage which is 3 volt, and if we divide this voltage by current that we know, 0.5, we obtain that resistance is 6 ohm. As you can see, a very simple task, but a few different ways of obtaining the final result.